Lesson 1: Points, lines, and planes. Starting with definitions, a point is denoted as such with a capital letter next to it. A a line, it extends infinitely in opposite directions. So it will be, let's say, colors here, green line, and it's defined with 2 points at the minimum. Let's say points B and C. And the notation for the line is denoted as point BC with a double-sided arrow on top. So BC denotes the line. The order does not matter. CB also denotes the line. It's also denoted sometimes with a cursive letter. So let's just say, like, I'll put the letter L here. So we could also denote it as L, line L. Okay. A line segment looks like this. It does not extend on both sides forever. So we have point A and point B. They're called endpoints. And we can denote this one as AB segment, or again, BA segment. The order does not matter. And one little difference between this notation, or let's say if I wrote simply AB without the bar on top, that will denote the length of the segment. Okay, so remember that. Now let's go on to array. Let's say we'll take yellow. Array will start at an endpoint, and we keep on going forever on one side. Okay, so again we have we can take 2 points, points G and point H, and to denote it, we'll denote it as such: GH with a one-sided arrow. That's a ray. Okay, again, HG will make no difference. It will denote the same. All right, moving on. A vertex. What is a vertex? Let's change colors again. A vertex is the point of intersection of two or more line segments, rays, or lines. So let's just say, for example, we have two rays, and we can put some points on there. So we have point A, point B, and C. And the vertex is what? The vertex is the intersection. So that's A. And we simply write A, vertex A. Let me make some space here. Okay. Next we have angle. So an angle is formed by two rays with the same endpoint, the vertex. So let's say, just like before, we had two rays and we'll put some points on there. Point A. Well, the point A is what? Is the vertex. And what is the angle? The angle is right here. And it's denoted in geometry angle A. Also, if we add some points on the rays, let's say we'll add point B and point C, we can also denote the angle as BAC, with the A being in the middle, or angle CAB. Okay. Triangles is a shape with three sides and three vertices. So I think you guys know what a triangle is by this point, but to be more precise, we'll call this point B, point A, point C, which A, B, and C are vertices, or each one of it. A is a vertex, B is a vertex, C is a vertex. And so those are the side. That's one side, that's another side, and that is a side as well. And to denote this triangle, we simply draw a little triangle and the vertices, or vertex ABC. And it could be called BCA. It would make no difference. All right, moving on. Parallel lines. Again, I think you guys are pretty familiar with parallel lines. Two lines that never intersect. So let's say we'll call this one L, and let's call this one M. So the parallel, because they're always the same distance apart, that would be one distance, another distance, always the same distance, and so they never meet. And to write that L is parallel to M, we would write L parallel to M. Okay. Next, let's talk about perpendicular lines. So we have again L, which is one line, and we'll call this one M, which is another line. We can make a little 90-degree angle sign, and basically this little square, this red square, means that there's a right angle, a 90-degree angle. And the way we would write that those two lines are perpendicular to each other, we would write L perpendicular to M. Okay. All right. So we say that a point has no dimension. We say that a line is one dimension. It has one dimension, or is one dimensional, right? And it extends infinitely in opposite direction. So again, let's just review for now, and then we'll do some little exercises at the end to check our knowledge. But we have a line here, and we'll put some points on there. F, G, H, right? So, and we can also add a cursive K. So, how could we name this line, right? So, this line can be named the following way: FG, GF, FH. I mean, any combination of those points, FGH, would qualify as naming the line appropriately. Or we can simply use the cursive letter K. Okay? Alright, moving on. Now, more definition. What is collinear? Okay, so collinear. If we think about how the word is built, co means with or sharing, and linear means a line, right? So, as an example, we say or H, I, and J. Those are points, right? H, I, and J. So we can say that points H, I, and J are, you guessed it, collinear, because the 3 points reside on the same line. Okay, let's take another example. Okay, now we have two rays, right? And we'll put a vertex, point E, F, D. Should have said D, E, F, will make more sense, right? So, guess what? Are those points collinear? You guessed it. They're not, right? Because they don't reside on the same line. This is D and E are on one ray that points in one direction. E and F are another way that points in another direction. So D, E, and F are not collinear. All right. Let's talk about planes. Not the one that fly. So a plane, it deals with flat shapes. such as squares and triangles. So a plane is two-dimensional, by the way. So we said that a point has no dimension, a line has one dimension, and a plane has 2D or two dimensions, right? Um, it's oftentimes shown visually this way, right? Um, so it's like a flat surface, and you have to understand that this little drawing here extends in all direction infinitely. Okay, we could make it larger, smaller, but it extends infinitely, so it's a flat surface. And the way we denote it, again, we can use points. So let's say point P, point S, point Q. We can also write a letter N here. So to denote it, we can write the capital letter N. That will denote the plane N. Or any 3 points. That's the minimum you need. 3 points that are not on one line, right? Because if they're on one line, then more than one plane could go through it, right? If you have P, S, Q on one line, there could be many planes going through it. One cutting it that way, another one cutting it another way. Like let's say it would extend this way. I'm not an artist, but hopefully you get the meaning. And so we can also denote it with those 3 points, P, S, Q, because they don't lie on the same line. And so we could write the plane P, S, Q, or again, the order does not matter, Q, S, P, and so forth. So now so earlier we had the word collinear, and now we're going to have the word coplanar. Coplanar. Again, co means with, together, and planar means plane. So sharing a plane, basically. So let's make a little drawing again. So the blue plane, and we'll make it green plane. Right? And let's stick some points on it. So P is on the blue plane, Q and R are all on the blue plane. And we'll call it S here. Again, points P, Q, and R are coplanar because P, Q, and R are all on the blue plane, right? And then we can say that S, which is on the green plane, S is not coplanar to P. All right? Because we have S on one plane and P on another plane. So they're not coplanar. And another important point, maybe we'll, well, actually, we'll get to it in a minute. Let's move on. Intersection of lines and planes. All right. So two lines intersect at, what do you think? A point. And so, as an example, we have a line, we'll put B and D, and another line, well, as long as they're not parallel, another line we can denote with A and E. And if we stick a point C here, we can see that the line BD, right, intersect line AE at a point, right, at point C. Okay, very important. Two lines, when they do intersect, they intersect at a point. Now, what about two planes? All right, so two planes, when they do intersect, because they could also be parallel, but if they intersect, two planes can only intersect along a what? Not a point, along the line, okay? So let's just draw it. So let's say we have a blue plane and we have a green plane. And so okay, again, I'm not an artist, but where would they intersect? They would intersect along a line that would look like this, line L, okay? So that's where two planes intersect along a line. Lastly, a plane and a line intersect at a point. Okay, so let's draw it again. We have plane M and we'll have a line that comes out of it. And that's keeps on going. And we'll put a point K and a point J, right? And the point J, that's where the intersection happens. So let's keep on going with this one. Okay, let's draw a cube. Okay, we'll call point A, B, C, D. We have E, F, G, H. Okay, so how many planes? So in a cube we have 6 planes, right? Right, it's just like a dice. When you roll a dice, you have 6 faces, and each face represents a plane. Okay, so the intersection of plane ABD, so plane ABD is what? ABD would be this plane, right? And plane DHG, so DHG will be this plane. So the intersection is a line because 2 planes, right? And the line would be the line DC. Okay. Okay, postulates and theorems. Moving on. All right. So proofs are used to communicate mathematical ideas. There are logical reasons used to confirm an idea. Postulates and theorems are used to support proofs. So what is a postulate? Okay. All right. Definition. So postulate. What is it? It's a statement that's already accepted as a fact. So we don't need to prove it. It's already there. It's already accepted, right? And a theorem is also a statement that has been proven to be true using other theorems or definitions or a combination of the two, or postulates. So a combination of postulates, theorems, and definition, basically. Okay. So we'll start with our first postulate. So what's a postulate? It's already a statement that's a fact. It's already accepted. All right, so we'll call this the line segment postulate. Okay, not all postulates have name. So actually this one we'll call it more precisely the segment addition postulate. I guess line segment postulates, there may be more than one, but this precise one is the segment addition postulate. Okay. It's not super important to remember what it's called, but the idea is more important. So let's first draw it so you guys don't get too confused. So what is this? It does not extend infinitely on either side. So basically it's a line segment. And we can name some points again. Point A, B, C. So we can see here that AB, which represent the length, plus BC is equal to AC. Right? And in words, we'll write the postulate this way. If B is a point on line segment AC, all right, so any line segment, but we'll call it AC, then AB plus BC equal AC. That's AB plus BC is equal to AC. So this is the thing to keep in mind. All right, moving on. Okay, as a review from earlier, remember that the difference between A, B and AB this way, right? What is the difference? So AB represents a segment, right? This is a segment. But AB represents the length of that segment. So let's say that this is 2 inches, then AB means 2 inches. That's the length. All right, keep that in mind. All right, moving on. Let's go through an example. All right, so example. We'll have, well, before we do the drawing, let's write the question. If R is between Q and S, all right, remember the postulate, and QR, okay, denoted this way, means the length is equal to 14 of certain units, and RS is equal to 17, then find the length of QS, right? So now let's put this in drawing. We have a segment and we'll put some QS. So this is the line segment QS, right? How do you represent the line segment? Just that way. All right, so we have if R is between Q and S, so we'll stick it right here, R. And we know that QR is 14 and RS is 17. So then we can say that QS, the length QS, is equal to QR plus RS. And we can now, since we have the units, QR is 14, RS is 17, so the total 14 plus 17 is 31. And there you have it. All right, let's take another example. All right. So another example. If U is between T and V, all right, then and TV is equal to 21. TU is equal to 2x, and UV is equal to 15. Find the value of x, right? So in those cases, do not try to do it in your head. We'll just start drawing, and we'll figure it out. So we have a line segment denoted with point T and V. And what is the length of the line segment TV? What it says right here, right, is 21. So we'll write it this way. We'll have a little length here, and that means length 21, right? And U is between T and V, so we have a U somewhere. All right, we'll stick a U here. And we are told that TU is equal to 2 times X, right? The length TU right here is equal to 2 times X. And UV, so the length UV is equal to 15. So we can say 15 here. And we're interested in the value of X, right? So we can do some algebra to figure it out. So we know that TU plus UV is equal to 21. So TU is 2x plus 15, that's UV, is equal to 21. All right, we can move the 15 to the other side. So we take out 15 on the left side and we take out 15 on the right side. So we have 2x is equal to 6, right? 21 minus 15 equals 6. And so now we can divide both sides by 2 to solve for x. So we have x is equal to 3. And there goes our answer. Okay? So by writing it, you can figure it out. All right. Let's talk about congruent lines. All right. Congruent. Um, congruent line segments. All right. Congruent line segments, not congruent lines. Okay. Because lines are infinite. So let's define congruent. The word congruent. So two line segments are congruent if they have the same length. Okay. Simple enough. So let's say we have line segment A B and it's 1 inch long, and we have another line segment, let's say C and D, and it's also 1 inch. Then we can say that line segment AB is congruent with line segment CD, right? So by the way, there is a sign, there's a symbol, there's a symbol to show congruency. And instead of saying AB, all right, let me make some space here. All right, so earlier we wrote AB is congruent to CD, right? Because they have the same length. But we don't have to write it this way. In math notation, it's written AB, line segment AB, and we'll write an equal sign with a little tilde on top. And it means the same thing. It's a symbol for congruence. So that just means AB is congruent to CD. All right? So you could read it, line segment AB is congruent to line segment CD. All right? All right, moving on. More notation. Let's write some line segments. So we have line segment EF. Okay, I'll change some colors. Line segment GH. Line segment, I'll make some yellow here. IJ. Let's go with black. Line segment KL. All right, and then we slice them with some bars. So the tick marks here that I wrote in black, they're sometimes used to show that line segments are congruent. So the same number of tick marks shows which segment are congruent to each other. So here we only have one tick mark, so we could write E EF line segment is congruent to GH line segment. All right, and let me take green for this one. So because we have two tick marks on each side, that means that line segment IJ is congruent to line segment KL. All right. All right, doing good. All right, let's take an example now. Which of the line segments are congruent in the following figure? So N M O P or P O, and then here we'll put some length, 3 inches. Put some tick marks here. What do you think? So we know that MP, right? MP is congruent to, that's a tilde by the way, to PO, right? Because PO right here is 3 inches long, and MP here is also 3 inches. So they're congruent. How about NM and MP? Well, we don't know because we don't know what NM line segment length is. But what we do know is that NM line segment is congruent to NO line segment, right? NM has a tick bar and NO also has a tick bar, and the tick literally means congruency. So that is it. All right, let's talk about segment bisectors. All right, so the midpoint of a line segment is the halfway point. Okay, it divides the line segment into two congruent, so congruent means same length, right? Segments. All right, so let's say we have a C line segment, and right in the middle we have point B. And so we can put the ticks for congruency on each side, which means that AB is congruent to BC, which means that B is the midpoint of AC. All right. And okay, a segment bisector is a line. A segment bisector is a line, ray, segment, or plane that passes through a segment at its midpoint. It bisects it, right? So bisect means to divide into two equal parts. The measure of each congruent segment is one half the measure of the original segment. Okay, so let's give some example, because sometimes all right, so let's say we have a segment FG, and then we'll stick a line this way, and we'll call this line L, right? And we'll put some tick marks, right? So we can say here that line L bisects, right, the segment FG, right? All right, how about if I again have the segment FG, but this time I have a ray that I will call BD, and if I put some tick marks here, what does that mean? That means that ray BD bisects FG, right? And it could be anything, right, that bisects it. Right now we showed like a line bisects it. That means it goes through the midpoint. A ray can bisect it. Another line segment could bisect it, or even a plane could bisect it. All right. So let's take a counter example, right? Let's say we have FG again. And then we have a line and we'll call it line J, right? So line J is not a segment bisector of FG because it does not bisect FG at its midpoint. Because if it did, we will have tick marks on each side, and we don't. All right. All right, finally, let's close it up with some questions. All right, check your knowledge. All right. 1. So for the first 4 questions, we're going to use this figure right here. Okay? So question 1. Name 3 collinear points. Name 3 collinear points. All right. So pause the video, of course, and every time you can pause the video and I'll give you the answer right away. All right. So and 3 collinear points. Collinear, right? They have to be on one plane? No, they have to be on one line. How about ABE, right? They seem to be on one line. So ABE would be the answer. All right, 2. Name 3 coplanar points. Okay, so BCD or DBC, all are correct answer. BCD, right? They all lie on the same plane. Okay. 3. Name the intersection of line AE and plane F. So remember, the intersection of a line and a plane is a point, and that will be point B, right? All right. Let me make some space and for the 4th question, which is related to the diagram still. Wow. I'm a master at erasing, apparently. There we go. Okay, question 4. No, not yet. Question 4. What are the other 6 names for plane F? Okay, 6 names for plane F, right? So, of course, we have F, that's 1. I forgot to write F, but we'll call this plane F, I'm sorry. So we could call it BCD, right? And all of the combination, right? BCD, BDC, CBD, don't do drugs, CDB, okay, we didn't start with a D, so we could have DBC and DCB, right? 1, 2, 3, 4, 5, 6. There you go. All right, let's keep going. All right, now for question 5 and 6, we're gonna use another figure. So here's the figure we're gonna use. All right, so let's put some letters on there. RS. So those are points, right? RST, Q, and M. This is an N. O, and P. All right. So question 5. I won't write it, but I will say how many planes are shown in the figure. All right. So we have. Remember, it's kind of like a dice. A dice has 6 sides. So this will have 6 planes, right? All right, 6. What is the intersection of plane MPT and plane M and R? So what is the intersection of plane MPT and plane M and R? And remember, 2 planes intersect not at a point, but at a line. So we have to find a line. So MPT, right? MPT. So that's the bottom plane. And M and R, and this is the left side sideways plane. So they will intersect at line MQ. You see it? Right? I think you do. If you look at it. All right. 7. What is the segment? What is the segment addition postulate? What is the segment addition postulates? Right? So as a reminder, the segment addition is if B is between A and C, then AB plus BC equal AC. All right? All right, we have 12 questions, so we're almost there. All right, so question 8. Find the length of segment GI. Right, so we have the segment GI. We have segment GI, right? And remember the segment addition postulate, right? All right. So the postulate says that GI is equal to GH plus HI. So GI is equal to 21 plus 36, right? So GI is equal to 57. Boom. Okay? Okay. 9. find the value of x. So line segment will have a line segment JL. So JL is a line segment with a point K in between. And the length of JL is 32. And we know that J and K, so JK is 2x plus 3, and the length KL is 19. So again, we can do some algebra. We have 2x plus 3 plus 19 is equal to what? To JL, which is 32. Now, we just have to rearrange, right? So we have 2x plus 21 is equal to 32. We can move the 21 on the other side by, well, we don't move the 21 to the other side. We subtract 21 from both sides. So we have 2x is equal to 32 minus 21. That would be 11. So x is equal to, you divide both sides by 2, 5.5, right? Did I make a mistake? I think I made a mistake. Let me see. Yeah. Let me rewind a little bit here. I made a little mistake. So we have 2x, 3 plus 19 is not 21, it's 22, equal 32. We subtract 22 from both sides, we have 2x equal 10. And so we divide both sides by 2, we have x equal 5. There we go. That's better. Alright. If you guys still here, congratulations. Alright, so question 10. So let's look at the figure here. So we have N O P M, and NM is 4 cm. The top is 4 cm. The right side is 5 cm, and the bottom side is 7 cm. So write a congruent statement for the congruent segments in the figure below, right? So we can only, congruency means line segments have the same length. So the only two that have the same length are NM and NO. So we can write NM, line segment NM, remember congruency, to NO. Boom. End of story, right? You guys did good. Or did you? Well, hit me up for math tutoring. Since we all suck at math, I can help you still, hopefully, if I suck less than you. So 11. Oops, maybe I should write a little better. Write congruence statements for the congruent segments in the figure below. Alright, so we have point Q, R, S, and T. And the tick marks are as such. So remember, some amount of tick marks means congruent. So if we have 2 tick marks and 2 tick marks, that means those 2 line segments are congruent. So on top we have QR, line segment is congruent to ST line segment. On the left side we have QS, has only 1 tick, right? So it's congruent to RT. Boom, end of story. And last question. All right. Be yourself. Okay, last question. What is a segment bisector, right? So it is whatever shape or line or segment goes through a midpoint. So in proper math language, a segment bisector is a line, ray, segment, or plane that passes through a segment at its midpoint. There you go.